Math 110, Solving Rational and Radical Equations, Section 3.4. With our rational equations, all it is are equations that contain rational expressions. Now when we solve for these, we have to find the least common factor or the least common denominator, however you want to phrase it, between every single term. Now there's an issue when it comes to solving rational equations, and this also includes radical equations, is that sometimes you have these things called extraneous solutions. Now you get these extraneous solutions whenever you have an equation that has an implied restriction to the domain. And so you just have to make sure that after you have your solution, you need to, when you plug it back in, you need to make sure that that works as well. And so the instances that it doesn't work, those are extraneous solutions. So our first example here, it's rational. We need to find that least common factor between everything on the bottom. And so this side needs a 2 over 2, and this side needs a 3 over 3. Now that the denominator is the same, and just to be consistent, now everything's the same. The reason why I didn't do that before, because it's 0. It's 0. And so now that all the denominators are the same, you don't have to worry about it. Now, I could just multiply everything by 6, and that would cancel it out, but don't. You can cross it out too, just however you want to think about it. And so now I have 2 times x minus 8 plus 3 times x minus 3. That's going to equal 0. Now I need to distribute that 2, and I need to distribute that 3. And then now combine like terms, solve for the variable. So I get 5x minus 25 equals 0. And when you go through and you solve it, you're going to get x equals 5. Now I have to take that value and I have to plug it back in and see if that's going to work. I have to check my solution. So when checking it, I'm going to get 5 minus 8 over 3 plus 5 minus 3 over 2. So now, simplifying this, I get negative 3 over 3 plus 2 over 2. And so that's just negative 1 plus 1, which is going to be 0. That right there, because I know that 0 equals 0, boom, I have, the solution works. So this could be my answer. For example number 2, I need to make sure that my denominators are the same, and so this is going to need x minus 3 over x minus 3. So now that all the denominators are the same, I can eliminate them, and so I'm going to get x squared plus 9 equals 0. Solving for x, minus 9 on both sides, I get x squared equals negative 9. Square root both sides, and you're going to get x equals plus or minus 3i. Now I have to check for extraneous solutions. I have to plug these values back in. So now that I have my solutions, I have to plug them back in. I have to check for extraneous solutions. So plugging it back in, I'm going to get 3i squared plus 9 over x minus 3 equals 0. So the 3 squared, that's going to give me 9i squared plus 9 over x minus 3. Now, yeah, I could just say, hey, my x, that's supposed to be 3i. But I was thinking ahead. And so the 3i and minus 3, that doesn't cancel out. But I know that this I squared, that's going to be negative 1. And so I'm going to get negative 9 plus 9, because negative 1 times 9 is negative 9, over 3i minus 3. And so that gives me 0 over 3i minus 3, which is 0. So that works. Now let's plug in the minus 3i. So if I plug in the minus 3i, now trying to reduce this, negative 3 squared, that's going to be 9i squared plus 9. Now if we look at that, this is turning out to be the same thing as that statement there, and so you can conclude that that's also going to be 0, and so that works, because you end up getting 0 equals 0. Example number 3, on this one here, what we want to do is we want to factor everything, right? Because we want to fill in those voids and make sure that we have the same common factors. So factoring everything, I'm going to get 2 over 3 times x plus 2 plus 1 over, this is x plus 2 and x minus 2, and this is going to equal 4 over x minus 2. So this one has a 3, this one doesn't, and this one doesn't. This has an x plus 2, this one does, this one doesn't. Okay, this one has an x minus 2, so does this one, but this one doesn't. And we have the 3, so that works. And now I believe that everyone has the same denominator. Yep, they all have x minus 2, they all have a 3, and they all have an x plus 2. So now rewriting this, like I can get rid of that now. I'm going to get 2 times x minus 2 plus 3, because 1 times 3 is that, equals 12 times x plus 2, because 4 times 3 is 12. Now distributing everything, you get 12x minus 4 plus 3 equals 12x plus 24. So I'm going to get 2x minus 1 equals 12x plus 24. So combining everything together, minus the 12x, minus the 12x, adding the 1, adding the 1. You're going to get negative 10x equals 25. Divide everything by negative 10. So this reduces into negative 5 over 2. So make sure you have to check. Okay? Make sure that you check for it. Now if you do plug it back in, so if you take the negative 5 over 2 and you do plug that back in, it's going to work. Okay? It's going to work. Now with radical equations, a radical equation is an equation in which variables appear in more than one radical. Now we have to use this principle of powers. It helps us, or it enables us to be able to solve these radical equations. Now it just states that if A equals B, and that's a true statement, then if I take both sides to some power, that's also going to be a true statement. And to think about it, I know that 2 equals 2. If I take that to the third power, and that to the third power, now I have 8 equals 8. They're the same thing. So solving this one, to get rid of this square root, I have to square both sides. And so now I'm going to get 3x plus 1 equals 16. Subtract 1 on both sides, you get 3x equals 15. Divide both sides by 3 and you get x equals 5. So now I have to take that 5 and I got to plug it back in. Okay, you got to take that 5 and you got to plug it back in. So plugging it back in, you're going to get the square root of 3 times 5 plus 1. Does that equal 4? So you're going to get the square root of 16 equals 4. 4 equals 4. So I know that works. And to do that, I use the principle of powers. Now sometimes what's going to end up happening is we're going to get a bunch of square roots, or you're going to get square roots that it's going to have other stuff happening to it. Now something that kind of guides you, you always want to isolate a square root. Once the square root is isolated, then take whatever power that you need to both sides to cancel it out. And just in case you get lost in the process, because sometimes the work can get a little messy, kind of following that guide of isolating root, power it or square it, or whatever it takes to undo it, isolate, etc. What's going to end up happening is it kind of like guides you into being able to do that. So in this case, that's what I want to do. I want to isolate. So subtract 5 on both sides. So I get the square root of x plus 7 equals x minus 5. Square both sides. And so I get x plus 7 equals, now this is FOIL, so that's x squared minus 10x plus 25. Now bringing everything to one side, minus x minus 7. I get 0 equals x squared minus 11x plus 16. Sorry, plus 18. So now I need to factor that. So that's going to be x minus 9 and x minus 2. And so that gives me the implied solutions of x equaling 9 and 2. But I have to check. I have to see if both of these solutions are actually going to work. So plugging them back in, I'm going to get 5 plus the square root of 9 plus 7. Does that equal 9? Right? I have to see, does that work? And so I'm going to get 5 plus the square root of 16, which is going to be 5 plus 4. And indeed, as you can see, that's going to equal 9. Now trying the next one. 5 plus the square root of 2 plus 7. Does that equal 2? You're going to get 5 plus the square root of 9. And then that's going to be 5 plus 3, which is 8. And we know that 8 doesn't equal 2. So 2 cannot be one of my solutions. And so therefore, my only solution is going to be 9. Next one, like I said, want to follow that pattern, isolate a root, then square or undo that root. So isolating this root, I want to, why not, I'll subtract the x plus 5 to both sides, the square root of x plus 5. And so now I'm going to have the square root of x minus 3 equals 4 minus the square root of x plus 5. So now to get rid of the root, we're going to have to square it. And so the square root and the square cancel out, and so I get x minus 3 equals 16 minus 8 root x plus 5 plus x plus 5 there in parentheses. Now I know I did that and I kind of expanded it, but if you want to FOIL for this, you can kind of double check the math there just to verify that. And so I have x minus 3 equals, now the 5 and the 16 come together, so that gives me 21 minus 8 square root of x plus 5 plus x. The x's are going to cancel out, and I can subtract the 21 to both sides. So I'm going to get minus 24 equals negative 8 times the square root of x plus 5. Divide everything by negative 8, and I'm going to get 3 equals the square root of x plus 5. Now that the square root's isolated, I mean, that's the reason why I was doing all of this, was to isolate. Because I was left with this mess here, and I was just kind of like, wow, I don't really know what to do there. That's, woo. And so my goal was just to get that next square root by itself. And so now that it's by itself, I can get rid of it again by squaring. And so now I get 9 equals x plus 5, minus 5 on both sides, you get x equals 4. So now I just need to check to make sure that this is going to work. So plugging it back in, I'm going to get the square root of 4 minus 3 plus the square root of 4 plus 5 equals 4. So I'm going to get the square root of 1 plus the square root of 9 equals 4. 1 plus 3 equals 4. 4 equals 4. Boom. It works. And that's going to be your solution.